Dear students, under the topic differentiation, we are now going to learn the applications of derivative. Now, we have to first understand y equal to f of x represents a continuous function of x. So, what is a continuous function of x? It means that the function y equal to f of x. So f of x does not have any breaks, jumps or holes in its graph. We can also say that changes smoothly, like when as x changes smoothly, the value of this f of x also changes smoothly without sudden jumps. So that is the meaning for a continuous function. And what is dy by dx? It is the first derivative of y with respect to x. So let us see the geometrical meaning of the derivative. So dy by dx represents geometrically the slope of the tangent at the point x comma y on the curve y equal to f of x. So geometrically we say that dy by dx represents the slope. And let us see the physical interpretation. Dy by dx represents the rate of change of the variable y with respect to x. So, physically it interprets that the rate of change of a variable with respect to another variable. Now, for example, if you take y as the distance traveled in time x, then the rate of change of y with respect to x gives us, that is the rate of change of the distance traveled with respect to the time, gives us dy by dx. That is, it represents the velocity of the point at time x. So, now before going into the actual applications that we are going to learn, let us see some basic concepts that we require. Now, if you take C equal to f of x to be the cost function for producing and marketing x units of the commodity, so we are going to represent C, which is equal to f of x, to be the cost function. Cost function for what? For producing and marketing x units of the commodity. So in that case, the average cost per unit will be given by the cost function divided by the number of units of commodity. So here we have x units of the commodity and the cost function is represented as C. So C divided by x gives us the average cost per unit. So if you want to calculate the average cost, you have to divide the cost function by the number of commodities. I mean number of units of commodities. Here we have x units of commodity, and so the formula is C by x. And the average cost is represented as C bar. Next we have the marginal cost per unit. It is the first differentiation of the cost function with respect to x. So if the cost function C is differentiated with respect to x, we obtain the marginal cost. Next we have the marginal average cost. That means what? We have to differentiate the average cost in order to get the marginal average cost. So what is this average cost? We have found here, that is C bar. So d C bar by dx gives us the marginal average cost. Next, if capital R represents the revenue, so first we learnt about the cost, and now capital R represents the revenue by selling x units of commodity. So for producing and marketing x units of commodity, the cost is represented as C. Now for selling, after selling and getting a revenue of x units of a commodity is represented as capital R, which will also be a function of the variable x. Now using this capital R, what will be the average revenue? So if you divide the revenue by the x units of a commodity, you will be getting the average revenue. So R by x, like how we did C by x, here we have to do R by x. And obviously what will be the marginal revenue? The first differentiation of the revenue with respect to x, that is dr by dx. So these formulas you have to remember. Also, if x is the quantity demanded and y is the price per unit of this quantity, then the revenue will be what? Obviously multiplying this x with respect with y. So x multiplied with y will give us the revenue whenever we have the quantity demanded and the price per unit. This is how we have to calculate the revenue. Next, we have the elasticity. So, what is elasticity of a function? The elasticity of a function y equal to f of x at the point x is defined as the proportional rate of change in y per unit change in x. So, it is the proportional rate of change and it is represented as eta, which is equal to x by y dy by dx. This can be asked under 2 mark questions. Using this, we have the concept of elasticity of demand. Now, what is elasticity of demand? The formula is given by y by x dx by dy, that is the reciprocal of the elasticity eta. So if you take the reciprocal of this, it will be what? Y by x dx by dy. So that gives us the elasticity of demand. And there is a relation between marginal revenue and the elasticity of demand, which is given by marginal revenue is equal to 1 plus the reciprocal of elasticity of demand. So this can also be written as 1 plus elasticity of demand. So if I write it as ed, the whole inverse. So in order to calculate the relation between the marginal revenue and the elasticity of demand, we will be making use of this. So with the help of all this, we will proceed to solve the problems under this topic. So kindly follow the next video lecture for problems under the applications of derivative. Thank you.